In the relatively small galaxy CID 947, which is 22 billion light-years from Earth, a black hole was discovered at its center, with an anomalously high mass, absorbing stars with their systems, planets, and who knows, maybe with the inhabitants on them. This paradox has led researchers to question all current theories about the life of galaxies. Of course, there are questions about how big a hole should be capable of destroying an entire galaxy, how it could appear, what exactly is happening with the galaxy at the moment, and whether a supermassive one can eventually swallow it whole. Well, let's try to figure it out. It is believed that there are currently only 3 types of black holes. Let's start from the smallest to the largest. Before us is the first type, primary or relic black holes, the smallest black holes, the formation of which occurred in the early stages of the development of the universe, which appeared as a result of the inhomogeneity of the Big Bang. The clumps of matter could shrink into black holes while the rest of the matter expanded. Yes, a black hole is not always something very large and heavy. The researchers suggest that the size of some primary black holes can be much smaller than the size of a proton. The second type is black holes with stellar masses. They arise as a result of the life of massive stars. We note that black holes are formed only from stars whose mass exceeds the mass of the Sun by 20 to 40 times. Another option for the formation of a stellar black hole is the accretion of gas. Let us recall that accretion is the fall of matter from the surrounding space onto a cosmic body. The gas falls on the neutron star until the mass of the latter reaches the maximum possible mass for neutron stars, in which case the neutron star collapses into a low-mass black hole. The third type, supermassive black holes, are mainly located in the centers of galaxies. Their mass can be up to 10 to the 9th power of the mass of the Sun. Among them is a massive black hole at the center of the Milky Way weighing 4 million solar masses. It is thought to have originated from a giant gas cloud that collapsed into dark matter, or is part of the first generation of heavy stars that collapsed into primordial black holes and then merged into a single supermassive black hole. It sounds more or less logical if it were not for one thing. The fact is that the CID galaxy 947 is a medium-sized galaxy, and about 4 times smaller than a personal path, but the black hole in its center is excessively huge in relation to it. Such galaxies have never been seen before. This is the first and only case so far. How did it happen? There are several hypotheses, the most obvious describing the gradual increase in the mass of a black hole, the accretion of matter onto a supermassive black hole. Another hypothesis suggests that such objects are formed during the collapse of large gas clouds and their transformation into a relativistic star with a mass of several 100,000 solar masses or even more. Such a star quickly becomes unstable to radial perturbation, due to the processes of formation of electron-positron pairs occurring in its core, and can immediately scale a black hole. Most likely, this happened to the recently discovered black hole Holmberg 15A, which has a mass of 310 billion solar masses. The supergiant monster is located in the elliptical galaxy Abell 85, in the constellation of the Whale at a distance of about 700 million light-years from the Sun. The galaxy gained notoriety after it was announced that it has the largest of any observed galactic nucleus, spanning about 15,000 light-years. Surprisingly, despite the scale of the black hole, the galaxy in which it is located is stable, unlike the Ripper CID 947. Initially, a group of astronomers were looking for normal black holes, both separately and inside galaxies, and not their exotic variants. The search was carried out using the Newton and Chandra orbital telescopes operating in the X-ray range of radiation. Galaxy CID 947 is the most ordinary galaxy, the mass of stars in which is only 44 billion times greater than that of our Sun. For comparison, this figure for the Milky Way, which is considered a fairly small spiral galaxy, is 64 billion solar masses, but the mass of the supermassive black hole at its center turned out to be prohibitive. According to calculations, its mass exceeds the solar one by almost 7 billion times, which makes this object one of the largest black holes in the young universe, and undoubtedly makes it the leader in the weight category of galaxies of this size. Such a result completely contradicts the established theories about the growth of black holes in the center of galaxies, which postulate that stellar megacities and heavyweights living in their center grow at approximately the same rate, and that their masses are always related as 1 to 500 ohms. In the case of CID 947, the black hole is only 8 times lighter than the entire galaxy. This means that it grew much faster than the rest of the stellar metropolis, as if eating almost all the gas, stars, and all the resources that are both inside the galaxy and from the intergalactic medium. But that's not all, there is another oddity. The black hole CID 947 has already reached the limits of its growth, but new stars continue to be born in the surrounding galaxies. Until now, this was also considered impossible, since the radiation of a black hole and the surrounding gas flows, in theory, should prevent the birth of new stars. It turns out a strange paradox, since a black hole both devours stars and contributes to their birth. Such a conclusion not only contradicts the theories of the growth of galaxies, but also indicates that supermassive black holes were not always the chokers of the star formation process, as they are considered today. All this indicates that the current understanding of the life of the early universe needs a fundamental revision. In any case, the CID Galaxy 947 is more than just a galaxy, it is a real find with its own universe.